All right, here, for this first one, in order to graph it, we start by going to our vertex, and our vertex here is going to be right 4 and up 1. And then from there, we would normally go over 1 and up 1. But in this case, because of the 1/2 out front, we're only going to be going up half as far, so this one's going to be going over 1 and up a half. All right, next up. Normally we go over 2 and up 4. But again, we're only going to go up half as far, so instead of going up 4, I'm going to go up 2. All right, then over 3. Over 3 is normally up 9, but half of 9 is 4.5. So we go over 3 and up 4.5. Then over 4 is normally up 16, because 4 squared is 16. All right, so we go over 4 and up 8, because half of 16 is 8. And then it looks like that's all I could fit on my particular graphing grid for this one, so then you draw the curve in through those points, and you have your graph. For this one, again, I start by applying the vertex, so we're going to go right 1 down 8. And then the 2 out front tells me that I got a vertical stretch by a factor of 2, so instead of over 1 up 1, we go over 1 and up 2. Instead of over 2 up 4, we go over 2 and up 8, because I'm multiplying my height by 2. And then instead of over 3 and up 9, we go over 3 and up 18, because 9 times 2 is 18. And then plot those points and go ahead and draw the graph through it. And then finally for this last one, it's actually going to be somewhat similar to the last one, but we got to get it to that certain point first, because we don't know where our first point goes. We got to figure out where that is. So we got to find the vertex. We got a formula for finding vertex, as you may recall. X equals negative b over 2a. And so we're going to use that for this one. So that's going to be negative. So then b is negative 20, so I put the negative 20 on top, over 2 times a is 2. Okay. Then, go ahead and simplify that, figure out what x equals. So that's going to be a negative 20 over 4, which is a negative 5. Now remember, whenever you have two negatives next to each other like that, a negative times a negative is a positive, so x equals positive 5. Once we know what that x value is, remember how we find the y? We plug it back in. So y equals 2 times 5 squared minus 20 times 5 plus 42. Now, when doing this, be careful of your order of operations, because we got this 2 times 5 squared. We're multiplying the 2, and we're squaring the 5. Which one gets done first? The exponent. Think about order of operations, PEMDAS. Exponents come before multiplication. So we do the 5 squared first, which is 25, then multiply it by 2, which gives us 50. Minus 20 times 5, which is 100, plus 42. Now we go ahead and do the addition and subtraction from left to right. 50 minus 100 is a negative 50. Then negative 50 plus 42 is negative 8. So now we have our vertex. Our vertex is here at 5, negative 8. Now that you know the starting point, you can make the whole graph, because you know also what the vertical stretch was. Because the vertical stretch is always just our a value. And notice our a value here is 2. So we have a vertical stretch by a factor of 2 in this problem. So instead of over 1 up 1, I do over 1 up 2, just like in the last graph that we did. And then just like in the last one, instead of over 2 up 4, it's over 2 up 8. And then instead of over 3 up 9, it's over 3 and up 18. Because whatever I normally would go up, I'm doubling it for this problem. So you plot those points. Make sure they're accurate on your paper as well, so you got a good reference going forward. And draw that curve through to finish off your graph. I'd like you please on your paper to factor these three equations. These three follow very directly off of those three that we did at the start of class yesterday. So if you end up going through these and you feel a little stuck, the first resource would be go back and look at the warm-up problems from yesterday because of those similarities. They'll help give you those hints on how to progress through. But go ahead and factor them. So for doing number one, first thing you'll notice, there's nothing you can divide all three terms by, but it is a quadratic. Since it's a quadratic, that is, it's to the power of 2, we can go ahead and factor it by doing the add 2, multiply 2. So we say what adds to a negative 9 and multiplies to negative 36. Since we're multiplying to a negative, we know one of them has to be positive, one of them has to be negative. And in this case, it's going to be a negative 12 and a positive 3. All right, then number 2. We start by looking to see, can I divide every term by the same number? In this case, yes, we can. I can divide 30, 42, and 15 all by 3. So I'm going to do that. First thing I do is I write down the 3 and then start parentheses, because this is distributive property, backwards basically. So 30 divided by 3 would be 10, and I'm not messing with the x's here. I'm not taking out any x's, so it's just going to stay x cubed. All right, I repeat the process with the other two, dividing by 3. So 42 divided by 3 is 14, so that's going to be 14x squared. And then plus 15 divided by 3 is 5. Now, to check ourselves, make sure we're doing all right here, I'm going to double check inside the parentheses. 10, 14, and 5. Can I divide them all by the same number? Other than 1? No. So there's nothing else I'm going to worry about dividing out of everything here. And then notice that this one's x cubed. It's not a quadratic here. And since it's not a quadratic, we can't factor it by doing a simple add 2, multiply 2. So that one's done. That's as good as it's going to get. All right, now on to number 3. And in doing number 3, we start by saying, can I divide all three terms by the same number? And the answer here is yes. We can divide all of those through by 4. So 4x squared. When I do 4 divided by 4, I get 1. And I don't really want to write 1x squared. I can just write it as x squared. So try to be in that habit. And then plus stays plus here. 36 divided by 4 is 9, so that's going to be 9x. Plus 80 divided by 4 is 20. All right, having done that, I'm going to look inside the parentheses, see if there's anything else I can do. I can't divide all three of those terms by the same number. But notice it is a quadratic. And since it's a quadratic, I can factor that one out a little bit more. And so this is basically our newer part that you're getting down, and the big focus for today, where after I've factored out that common term from everything, in other words, divide everything by the same number, I'm going to factor the quadratic that gets left behind. And so what adds to 9 and multiplies to 20? 4 and 5. So we get 4 times x plus 4 times x plus 5. And then that is completely factored. And just a reminder, what's that factoring mean? It means if I wanted to, I could multiply this back out and I would end up with what I started with. And we would. We don't need to do it. But if you're ever questioning yourself, wanting to make sure you're doing it right, you can do that to be able to know that it is in fact the same. Today we're adding a little bit of a new wrinkle though. Please write this equation down on your paper. You'll notice what's different about this equation from the previous ones you've seen. We got a negative in front of it. And we're going to have to see how to deal with this negative that's sitting out front of x squared. So to start with, I want to show you what we can't do. So don't write this part down. Because sometimes people think, okay, well, I'll just divide everything through by 2. But if we do that, you notice the x squared is negative? If x squared is negative, I can't do the normal add 2, multiply 2. It doesn't work unless it's just a plain old x squared. So instead of factoring out 2, we're going to factor out negative 2. I figured. So let's factor out a negative 2. When we do that, we get a positive x squared. That's what we want. We always want x squared to be positive. Then, if I'm going to divide 30x by negative 2, though, that means it's going to become a negative 15x. So our plus becomes a minus here. Same thing happens with the 200. Our plus 200 becomes a minus 100. When you divide out by that negative, it flips every single sign. All right, and having done that, we now can take a look at the resulting quadratic that's left inside. Can that one be factored? Are there two numbers that add to negative 15 and multiply to negative 100? Actually, there are. So our winning combination is a negative 20 and a positive 5. Because those multiply to negative 100 and add to negative 15. Notice that negative 2 that we factored out at the start? It's still sitting out front of the parentheses. Make sure you keep that carrying down each step of the way. So this one's a little bit different yet. In some ways it's easier and in some ways it's harder. Write down number 5 on your own paper there so you have it and can be writing down the answer as we do it. All right, so for doing this one, you know how I said that we couldn't do the add 2, multiply 2 if the x squared was negative? Same thing here. I gotta make x squared positive. So I'm actually gonna factor out a negative 1 out of every term. When we do that, negative x squared becomes a positive x squared. Plus x becomes minus x. And plus 42 becomes minus 42. Although that looks a little funny, doesn't it? We don't normally leave it written where we got a 1 written in front of the parentheses like that. So rather than writing it as negative 1 in front of the parentheses, let's simplify that down and just write it as a negative in front of the parentheses. It's a little bit cleaner, a little bit tidier, kind of like the difference between writing x or 1x. Speaking of 1x, though, you notice that's what we're adding to here. We're actually adding to a negative 1x and multiplying to negative 42 in this problem. Our negative is still going to hang out up front, but what two numbers add to a negative 1 but multiply to a negative 42? Negative 7 and 6, which then gives us our final factored form for this one. So notice part of the reason why we factor that number in front of x squared out is because it does give us something that we can then factor. Without doing it, we can't factor it really. All right, having seen those, I think you're ready to go ahead and do these. Do these 3 problems on your own, then we'll come back together, we'll take a look at the answers, make sure you're on the right track. But if you got these 3 and can do these 3 well, you're going to be fine for doing all the homework and stuff that's on the horizon. So for number 6 here, the first thing we do is we look to see, can I divide every term by the same thing? And in this case, yes, I can divide them all by 5. So we're going to do that first. So that's going to give me 5 times the quantity x squared plus 9x plus 18. Then we say, are there two numbers that add to 9 and multiply to 18? And the answer is yes. The 5 continues hanging out front. Our two numbers that add to 9 and multiply to 18 are 6 and 3. So our final answer here is 5 times x plus 6 times x plus 3. Number 7. Same deal on number 7. In this case, though, we're going to be dividing everything through by negative 5. When you do that, that gives you x squared plus 23x minus 50. And then again, we ask ourselves, are there two numbers that add to negative 23 and multiply to negative 50? And the answer is yes. They are 25 and negative 2. Because 25 times negative 2 is negative 50. And 25 plus a negative 2 gives us 23. All right, and finally, for number 8, we're going to factor out a negative 1. But remember, I don't really want to write negative 1. I'm just going to write negative parentheses. And we flip all the signs. So x squared minus 18x plus 81. That's an 18, not an 81. All right. Then, are there two numbers that add to negative 18 and multiply to 81? Yes.
Yes.
It is negative 9 and negative 9. But since it's both negative 9, I don't want to write x minus 9, x minus 9. I'm instead going to write x minus 9 squared. I want to write it as succinctly as possible. And writing it as squared is more succinct than x minus 9 times x minus 9.